right, let's finish up DSMA 2. This is part 2. So we're going to keep going. Looks a little more complicated, but it's really not. Let's go ahead and take care of our distributive property first. That means we take 3 times x and 3 times 1. And then remember, before we start moving everything around, we want to make sure that we clean up each side. Well, the left side is 7x minus 6, so there's nothing to clean up. But on the right side, we could add the 3x and the 4x, and we also can add the two numbers, the 3 plus the negative 9. So let's go ahead and do that. So 3x plus 4x gives me 7x. 3 minus 9 gives me a negative 6. Whoa, look at that. Those are the same. So let's go ahead and move. We can move stuff. Again, I learned to move the x's first. Let's go ahead and do that this time. So if I move the 7x and subtract it and move it over here, look what happens. Everything goes, all the x's go away. On this side, I have 0. On this side, I have 0, which is a problem. And now I'm left with negative 6 equals negative 6. If you had moved the negative 6 first, you would have ended up with 0 equals 0. And so this is a true statement, but I can't solve. I can't end up with x equal to when I don't even have an x. So here's what happens. All of the solving problems that we did in part 1, what happened is that was 2 lines and we were looking at where those intersect. Okay, well with these two, once we cleaned up both sides of the equal sign and started looking at that, we had 2 lines. Oops, this is the one that, I take that back. That's not this one. That's when they're parallel. This one is we had 7x minus 6 here, and then we had 7x minus 6 right on top, right? And so every single point on this line is an answer. So what we're going to say is that the solution set is all real numbers. Now, the way we look at that, this is the set of x's such that x is all real numbers. Okay, so the set of all x's such that x is a real number is really how this works. And so for this problem, I think that's all we're going to do. So what we're going to, as soon as we see that the x's are gone, we lost the x's on both sides, so there's no way to get x equal to. We then check and see if we have a true statement or a false statement. We'll do a false in a minute. If we have a true statement, that means that every single x is an answer. Sometimes you also see this referred to as infinite solutions. That is correct. And that is because every single point on that line is an answer, is a solution. I could put 10 in there. If I put 10 on both sides, I would get 64 equals 64. I could put 0 in there and I would get negative 6 equals negative 6. I could put 1 in there and I get 1 equals 1. No matter what number I put in for x, I am going to get a solution. And so again, that we're either going to say that it's all real numbers or that it's infinite solutions. Depends on the problem. Okay, so let's clean up this one. We've got a distributive property to take care of. So we have 8 times x and 8 times negative 1. And then we also have a minus 7 there, but that's not multiplied because it's outside of the parentheses. Then we have 4x, and then we have 4 times negative 3 and 4 times x. Ooh, that's out of order. That's kind of strange. So 4 times negative 3 gives me negative 12. 4 times x is 4x. So let's clean up both sides. Looks like on this side I can add the numbers together. On this side I can add the x's together. So that gives me 8x minus 15 equal 8x minus 12. So it almost looks like something's going on again, right? Again, you can do it either way. You can move the x's first, or you can move the constants first. I like to move the x's. So let's, I'm going to subtract 8x from this side. But when I do that, and I subtract 8x from this side to be balanced, look what happens. My x's go away again. And I end up with negative 15 equal to negative 12. If you moved the constants or the numbers first, you would get 0 equals 3. Still a problem, right? Either way, it's a problem. And so this is the one I started to draw before. So all of the ones in part 1, the lines would intersect at one point, and that's why we were able to have a solution. I cannot get this stylus to work in there. For the problem right before, we actually had 2 lines right on top of each other. With this one, we have parallel lines. And so the problem is they never intersect. They're parallel and they never cross. And since they never cross, we're going to say that the solution is this, we call this the null set. Basically, what happens is there's no solution. So if you see that you get a false statement here, this doesn't make sense. Negative 15 can't equal negative 12. If you did it the other way, 0 can't equal 3. Then that would be a false statement, and therefore there's no solution. We'd have to go back to the drawing board if we were trying to figure something out with this linear equation. Now, sometimes we have 2 variables. This happens a lot in algebra. And so for this one, we are solving the following equation for y. That means we want y all by itself on the left-hand side, and we want everything else on the right-hand side. But let's clean it up first. Look what happens over here. We have minus a negative. So this is the same thing as -1 times -3. So let's clean that up. So we have y minus 6 equals 4 times x. And -1 times -3 is going to give me a positive 3. This is really important, and this is needed for the college algebra section 2.3, where sometimes we're going to have minus a negative, and we want to go ahead and change that to a positive. But remember, that's really a -1 sitting out in front of the parentheses. We just don't write the 1. Okay, so now we can do our distributive property. So we have y minus 6 equal to 4x plus 12. 4 times x and 4 times 3. Now, it's going to be tempting to bring that 4x over to the left, but we only want the y on the left-hand side. We want this to be what we call a linear equation. And so we are going to go ahead and move the 6. This is minus 6, so let's add 6 to both sides. So on this side, I just have y. That's what I want. On this side, I have 4x plus 18. And so we're going to learn how to graph this way without having to substitute. This is also what we would have to do to get it into our graphing calculator. You have to have y by itself and everything else on the other side. And we like to write it with the x first and then the constant. So this would actually be our answer, the 4x plus 18. That's what's going to go into the box here because we solved the equation for y. And y is sitting right here. All right, let's try another one. First thing we're going to do is clean up this negative and a negative, right? Remember, this is really -1 times -5. So that would give me y plus 5. Let's go ahead and distribute on this side. So -7 times x gives me -7x. -7 times -7 is a positive 49. Watch those signs. They get us every time. They get all of us, so don't worry, but be careful. Okay, so -7 times x gives me -7x, and then -7 times -7 gives me a positive 49. I'm almost there, but I want y by itself. So since I have a plus 5 on the left, I'm going to subtract 5 to get rid of everything on that side, but that means I have to also subtract 5 on the right. And so finally, I have y equal to negative 7x plus 44. And again, we like to put the x first. We're very orderly in algebra. We put the x and then we put the constant in. So you knew we had to do it and get to fractions, but it's okay. We're going to get rid of the fractions. We have 16 minus x over 3 equals x over 5. Now we are not going to mess with fractions because why do that when we don't have to? If we were simplifying, we would have to, but since we have the equal sign, we can actually take care of those denominators. So first we have to find the least common denominator. In this case, we have, well, technically we have 3 denominators. We have 1 times 3 times 5, right? Those are our 3 denominators. The 3 and the 5 have nothing in common, and therefore we would just have to multiply them together. Okay, so let me rewrite with some space in here. So what we're going to do is we are going to multiply by the least common denominator. But we have to multiply every single term to keep it balanced. So we're going to multiply, and that was 15, right? 1 times 5 times 3. So I'm going to multiply everything by 15. For the fractions, I'm going to do 15 over 1. And then we're going to go ahead and clean this up. So 15 times 16 is 240. Put it in your calculator. Now over here, I have 15 divided by 3. So 15 divided by 3 is going to give me 5. And so see how I got rid of the denominator? Yay. On this side, I have 15 divided by 5, which is 3, but don't forget your x. For both of those, don't forget your x. Now, look at that, no fractions. So I can go ahead and finish. I'm going to do it. I don't like it, but I'm going to do it and move the x's over to the right-hand side. So on here, we have plus 5x or minus 5x. So I'm going to add 5x. Right, that gets rid of everything over here. Then I have 240 equal to 8x. That gives me 30 equal to x, or x equal 30. And that's my solution. You can check your work. You could put 30 into the x on both sides and clean it up and make sure that both sides are the same. See, fractions aren't so hard. Okay, one more. It says solve. We've got 3x over 2 minus x equal x over 10 minus 8 over 5. So we actually have 3 denominators we have to look at. But look at this. The 10 is 2 times 5. So all of those numbers go into 10. 2 goes into 10, 5 goes into 10, of course 10 goes into 10. So our least common denominator is going to be 10. Now you could multiply by, you could do 2 times 10 times 5, which would get big. It would be 100. You could do it. It'd be okay. But that wouldn't be the least common denominator. So let's go ahead and multiply this out by 10. So everything has to be multiplied by 10. Don't forget the one here. Even though you don't see a fraction, it technically is a fraction because it's over 1. Okay, so multiply every single term by 10, or 10 over 1 for the fractions. And then let's clean these up. So on this first one, we have 10 times 30, or excuse me, 10 times 3 is 30 divided by 2, right? This very first term. I have 10 times 3, which is 30, divided by 2 gives me 15x. Then I have minus 10x, right? We don't have to do anything with that middle term. The next term over here, I have 10x over 10. So 10 over 10 is 1, and therefore I end up with 1x. Again, we don't usually write the 1. And then finally, this last term, we can do it a couple different ways. 5 goes into 10 2 times, and then 2 times 8 is 16. Or you could do it 10 times 8 is 80, and 80 divided by 5 is 16. So either way that you want to do that. All right, so let's clean this up. On the left here, we have 15x minus 10x. That gives us 5x. On the right, there's not really anything we can do to clean up because they're not like terms. So let's move our x over. Minus x minus x. Whoops. That leaves us with 4x on this side, negative 16 here. Ooh, my stylus is acting up. Then we're going to divide both sides by 4, right? Because it's 4 times x. And so that leaves us with x equal to negative 4. Okay, so try some of those fraction problems in the homework. There's just a couple of them. And then be sure and come back to this video if you need a little help, or of course, reach out to us.